Okay, I am given this equation which contains cos and sine, and I can see here that in order to change it into this equation here, I've got to replace cos squared. Now I know that there's an identity which connects sine squared and cos squared, and that looks like this: sine squared x plus cos squared x is equal to 1. Now that means that instead of cos squared x, I can write that cos squared x is equal to 1 minus sine squared x. And what I'm now going to do is I'm going to take my original equation, so 2 cos squared x is equal to 5 sine x minus 1, and I'm going to replace the cos squared here with the 1 minus sine squared x from there. So that is equal to 5 sine x minus 1. If I just multiply out the brackets, I've now got 2 minus 2 sine squared x is equal to 5 sine x minus 1. I want to make it into a quadratic equation, so I'm going to make this side 0. I can see that my 2 sine squared x is going to have to be positive, so I'm going to add 2 sine squared x to both sides. So this is going to become 2 sine squared x. The 5 sine x stays there, and I'm also going to subtract 2 from each side to make it minus 3. And there's my equation. Okay, next thing I'm asked to do is hence solve the equation. Now hence means that I must use what I've just found. So I'm going to take this equation and I'm going to factorise it. Now you could just factorise it directly. Some people like to rewrite it as something like 2x squared plus 5x minus 3 is equal to 0, just to make it a little bit easier to factorise. So we can see that we're going to have a 2x and an x. We're looking for 3, so I'm going to put a 3 there and a 1 there. I'll make that positive and that negative. Then I can just check I've got 2x squared plus 6x minus x, so that's 5x minus 3. Okay, so over here it's going to have to be 2 sine x minus 1, and here sine x plus 3. Now from this, if it's a quadratic equation, then either 2 sine x minus 1 is 0, well, that means that sine x, or 2 sine x minus 1 is equal to 0, means that 2 sine x is equal to 1, which means that sine x is equal to a half. Or from this one, sine x is equal to minus 3. Well, there are actually no solutions, so I can forget that. Okay, the sine of an angle cannot be bigger than 1 or less than minus 1. So I just need to find all the solutions, in this case between 0 and 360, where the sine of x is equal to a half. First thing I'm going to do is use my calculator. So sine to the minus 1 of a half, and from my calculator that gives me 30 degrees. So I know that one of my solutions is 30 degrees. To find the other angle, then I'm going to draw the sine graph between 0 and 360. So there's 360, there's 180. 30 degrees is here. If I go up to the curve and across and do the same thing, if this angle here is 30, then this angle here is also 30, which means that my other angle is 150 degrees. I can also use the cast diagram, which some of you might know about, where this goes ASTC. One of my angles is 30 degrees, which is here. Sines are positive in this quadrant, but also in this one. So I can draw my other 30 degrees there. So one of my angles I can see is 30. The other one is this angle, which is again 150 degrees.